Good afternoon, everyone. It's a great honor to be here today as the anchor of this event. I would like to welcome all distinguished guests, faculty members and students who have gathered today here to celebrate the awarding of the title of Honorary Professor of Electrical and Computer Engineering of the National Technical University of Athens to Professor Ronald Schafer. First, I would like to call the Rector of the National Technical University of Athens, Professor Boudouvis, to give an opening speech.
Good evening, everyone. Dear Dr. Schafer, dear Ms. Schafer, dear Dean, dear colleagues from the National Technical University of Athens and other institutions, ladies and gentlemen, it is my pleasure and honor, representing as Rector the National Technical University of Athens, to participate in this ceremony for awarding Dr. Schafer the title Doctor Honoris Causa, Επίτιμου Διδάκτορα in Greek, of the National Technical University of Athens, upon the recommendation of the School of Electrical and Computer Engineering and the subsequent approval by the Senate. Ronald Schafer is honored today for his pioneering scientific contributions in and for shaping the field of digital signal processing. He received a bachelor's and master's degree in electrical engineering from the University of Nebraska in 1961-1962. He received a PhD degree from MIT in 1968. From 1968 to 1974, he was a member of the Acoustics Research Department at Bell Labs in Morey Hill, New Jersey, where he contributed to some of the earliest research on digital signal processing. In 1974, he joined Georgia Tech as a professor of electrical and computer engineering. During the 30-year career at Georgia Tech, he helped to introduce thousands of students to the field of digital signal processing, and he supervised graduate student research in speech processing, image processing, biomedical signal processing, and communication signal processing. Our own Petros Maragos was among his advisees. In Georgia Tech, he and his colleagues built one of the world's most prestigious signal processing laboratories in academia, at that time, the Center for Signal and Image Processing. He retired from Georgia Tech as Professor Emeritus in 2004 and joined Hewlett-Packard as an HP Fellow at the HP Laboratories in Palo Alto, California. He retired from HP in 2012 and is now an adjunct professor of electrical engineering at Stanford University. Among his many distinctions, he is a member of the National Academy of Engineering, a fellow of both the IEEE and the Acoustical Society of America, and a recipient of the IEEE Education Medal. Professor Schafer has pioneered research in digital interpolation and time frequency analysis synthesis. It's been applied in today's digital speech processing systems for data compression, for mobile phones and voice over IP, and for voice I/O for computers. His contributions in areas such as iterative algorithms, mathematical morphology, 3D reconstruction, statistical modeling and interpolation have had important impact in areas such as medical imaging, neurobiology, wireless communication systems, and digital photography. Since I'm not an expert in his area, although chemical engineers like myself have to deal with digital signal processing in various processes and systems of their interest, including biological ones, I try to look a bit closely to his research endeavors so as to understand better and to identify interdisciplinarity. So I came across capstone analysis, a term which was not familiar to me as opposed to the terms I just mentioned. And I learned something new. Actually, I got the essence of it, which in his words goes as follows. It was observed that using these new Fourier computational techniques, you could measure a power spectrum and compute the logarithm of it, and thereby decompose convolutional type processes into a sum. But while doing this investigation, I ran into a series of findings about Dr. Schafer, his advisor Al Oppenheim, etc. And I will share some with you which are of special interest, I think. To his own children and the multitude of students, he has often quoted an instruction from the MIT catalog of 1963. In quotes, a student is expected to study at least 3 hours outside of class for every hour in the classroom. To his chagrin, this suggestion was not generally met with an enthusiastic response. In an interview in 1998, he said, Petro, this will make you blush. I had a very outstanding student named Petros Marakos, who is now a professor at Georgia Tech. Petros got me interested in the subject of nonlinear signal processing, particularly something called mathematical morphology. So he and I did quite a bit of work together in that field, and I have continued to have an interest in that. So my interests after Bell Labs have broadened. Unquote. In a relatively recent interview as adjunct professor at Stanford, he said the following: I think it is important to understand the signal and to do that in terms of the mathematical theories that represent signals, and not just treat the machine learning algorithms as a black box that you throw it enough data and out comes the answer. And this statement, to my opinion, pertains to many fields and disciplines, and especially to current and future developments related to the closing phrases in that interview. He closed that interview as follows: all of that now referring to digital signal processing algorithms, the filters, sparse Fourier transform, and so on, and then developments in integrated circuits, leads to these ideas of machine learning, where you basically learn a nonlinear digital signal processing system whose purpose is to take signals and produce information from them. So it's been a very exciting time over the past 50 years or so. Lots has happened, there's lots left to be done. Upon closing, let me share with you some relevant non-expert thoughts based on the current disasters that are hitting Greece, the unprecedented floods, a few days ago in some areas, and recently the catastrophic wildfires. I think that coping with natural disasters, and especially emergency management, is a grand challenge and an area where digital signal processing can be of immense value. This, of course, pertains to other type of catastrophic events. Today is the 22nd anniversary of 9/11 of the Trade Center massacre in New York. Engineers in the field and those in academia have a key role for the development and use of increasingly advanced technologies towards a holistic, sustainable, and efficient emergency management system. Highly relevant to that is the advancement of the public warning system so as to reach population at a large scale in a timely manner. The signal should be resilient to ground destruction and independent of terrestrial mobile networks. In that direction, the emergency warning satellite, part of Galileo, the European Union's global navigation satellite system, is designed to be received directly on any device capable of processing Galileo signals: smartphones, car navigation, fixed receivers on the roofs of buildings for display on public billboards, and more devices that are connected to the European Global Position System. These are important matters which affect the lives and properties of thousands of people and actually the state of the country. With that, dear Dr. Schafer, I wish you to see and enjoy as many as possible developments that are ahead, and I welcome you once more to the extended NTUA family.
Now, I would like to invite the Dean of the School of Electrical and Computer Engineering, Professor Panagiotis Tsanakas, to deliver an address to the audience.
Thank you. Dear esteemed Rector, Vice Rectors, distinguished guests, it's a distinct honor to present Professor Ronald Schafer for the Honorary Doctorate Awarding Ceremony. In my capacity as the Dean of the School of Electrical and Computer Engineering, I'm privileged to recognize his extraordinary contributions to the world of engineering, education, technology and innovation. Ronald Schafer's impact in the field of digital signal processing is nothing short of transformative. His pioneering work in signal processing techniques has not only advanced our understanding, but has also paved the way for numerous technological advancements. His dedication to education, technology and innovation perfectly aligns with the values of our university. Professor Schafer is highly cited and recognized as an expert in signal processing and its applications in fields like audio, speech and other technologies, combining rigorous theory with practical algorithm development. In conclusion, Ronald Schafer contributions to science, technology and innovation, spanning the fields of signal processing, its strong connections with machine learning, and its applications to speech and other multidisciplinary areas are nothing short of exceptional. His work has left an indelible mark on these fields, and it is with great pride that we present him with this honorary doctorate. We are inspired by his dedication to advancing scientific education and technological knowledge, and his role in the future of electrical and computer engineering. We look forward to the continued impact of his work for all the generations to come. Once again, congratulations, Professor Schafer. Thank you.
And now I would like to invite Professor Petros Barakos to describe and present the work and contributions of Professor Ronald Schafer.
Dear esteemed Rector and Vice Rectors, dear colleagues and students, dear distinguished guests, it's a great honor and prestige to present today the academic work of Professor Ronald Schafer in this great celebration for this awarding of the honorary degree from NTUA. I will try, within a very brief time window, I will try to sample and summarize some of his accomplishments throughout his very long and distinguished career. Well, his first work experience started as an instructor at MIT for the duration of 4 years, and then followed a very successful career as a distinguished researcher at Bell Labs with the legendary their speech group in the Acoustics Research Department, where he worked for 1968 until 74. And as our rector very nicely summarized, it was there that and at MIT during his doctorate that he co-founded digital signal processing and its application to speech. After Bell Labs, he joined the faculty of Georgia Tech at the Electrical and Computer Engineering School for 20 years as a chair professor, and since then through the ranks of Regents and Institute Professor until 2004. During this 20-year period, there are many nice accomplishments, both in education and research, which I will describe and summarize later. After Georgia Tech, there was a period where he joined Hewlett-Packard as an HP Fellow, and for 8 years, and since 2007 he teaches the signal processing courses at Stanford University, the Electrical Engineering Department. Well, throughout his long career, he has co-authored many important and groundbreaking books. It's actually hard to think of signal processing, education and research without the two fundamental textbooks. The digital signal processing, 1975, the first edition, and second, the digital processing of speech signals, 1978, the first edition. These books, both of them, are deep, they are thorough, full of pedagogic examples and exercises for the students, and offer wide coverage of these fields, not only for students but also for researchers. And let's go with the first one. Well, this is the first legendary textbook on digital signal processing. Essentially, it was the one that actually defined the field of signal processing. And it gave it its first academic identity, both as a graduate course but also as a scientific field. After this first edition, there have been two more editions of this digital signal processing book, called now Discrete Time Signal Processing, to also accommodate the fact that there are some systems which operate in discrete time, but they have analog signals in and out. The second seminal book is the 1978 version of digital speech processing, which actually gave the computer speech processing community and area its first academic identity, again as a graduate course but also as a scientific field. And in addition to that, this book has served for many decades as a fundamental reference for all researchers in speech and language technologies. Both this book, as well as the previous one, the 1975 digital signal processing book, they are classics now, of course, and their versions have served, and they still continue to serve, two scientific communities: the signal processing community and the speech and language community, for more than 4 decades, in terms both of education needs as well as in terms of the needs of research. And both now these foundational and groundbreaking textbooks became, when they first appeared, they became immediately and enthusiastically, they were accepted worldwide, and they sparked a lot of interest among lots of faculty and many students worldwide to do research in these new fields. So at NTUA, similarly at NTUA, this also, the same thing happened. Towards 1980, many students from the NTUA Electrical Engineering School were attracted to do research in these new fields, DSP and digital speech processing and its application to speech. And here's one such example of a diploma thesis on automatic recognition of Greek phonemes based on adaptive digital filters. And during which the first Greek word was digitally sampled at NTUA. This word was the word Ella, which means come in English. And there have been some other words as well, in addition to Ella. After that, there have been many students from NTUA Electrical Engineering School who went on to do research at the Georgia Tech DSP group and obtained their PhD. Both then during the first decades as well as now. A third book that made a significant impact in education is this textbook called DSP First. This actually introduced a new approach in undergraduate electrical and computer engineering education, and they used it as the basis for a second-year sophomore core curriculum course. The authors actually, through this book, they were able to introduce DSP early in the engineering curriculum and use it as a vehicle for explaining engineering ideas, not only from the electrical engineering point of view, but more generally to undergraduates. So it's another approach to engineering undergraduate curriculum. Professor Schafer has received many teaching awards, both from Georgia Tech, as well as top awards from Ivy League, including the 1992 Ivy League Education Medal, the 2000 Carl Friedrich Gauss Education Award from the Signal Processing Society, Ivy League Signal Processing Society, the 2003 Ivy League Education Society Award, and this year the prestigious Athanasios Papoulis Award from the European Association for Signal Processing. This award was given to him for outstanding contributions to education in the signal processing and speech processing disciplines. In addition to his outstanding work on engineering education, Professor Schafer has also made fundamental contributions in various research areas. First, during the early DSP years, as again nicely our rector, Professor Boudouvis, summarized, he co-developed the mathematical and algorithmic aspects of the capstone. A very nice computational tool, novel, and he also expanded it with novel applications to nonlinear filtering and speech analysis, especially for both voiced and unvoiced speech. Afterwards, from his research, new approaches followed in the areas of digital filter design, digital interpolation, short-time spectrum analysis based on digital computers. All these areas were actually new, so these approaches were considered to be breakthrough approaches in these fields. His research continued at Georgia Tech, where with colleagues and graduate students he co-developed areas like iterative restoration algorithms and morphological filtering. In addition, he has served IEEE under many roles, including serving as the president of the Signal Processing Society for 2 years and vice president for the previous 2 years. During his faculty years at Georgia Tech, he actually founded and led very successfully the DSP group there. And this group grew very successfully and became the nowadays Center for Signal and Information Processing. And Professor Schafer contributed a great deal to this development from the initial DSP group to this Center for Signal Information Processing, and for a large period of time he was leading all these efforts and the group. And this center now is perhaps the largest university center worldwide in signal processing and its applications, and it has more than 20 faculty members. His research contributions led to a number of very significant research awards from IEEE and other societies. Let me mention some of the most well-known. He's been elected a Life Fellow of IEEE. He has also been elected a Fellow of the Acoustical Society of America, and he has been elected a member of the United States National Academy of Engineering. Several other research awards from Georgia Tech and other areas. 1979, he received the Technical Achievement Award from the IEEE Signal Processing Society. 1980, the Emmanuel Pior Field Award from IEEE, and the most prestigious Signal Processing Society Award, the Norbert Wiener Society Award from IEEE in 1982. He has also received 3 medals from IEEE, 1984, 2000, and the prestigious Jack Kilby Signal Processing Medal. With contributions from Professor Schafer's work and from the work of other pioneers in the areas of signal, speech, and image processing, the Signal Processing Society has actually evolved nowadays into one of the biggest in terms of membership, as well as the most active IEEE scientific societies, and some of its most popular application areas and commercial products of broad appeal include the following: cell phones, MP3 and digital audio, digital radio, voice over IP and teleconferencing, Zoom, for example, high definition TV, hearing aids, wireless communications, digital cameras, biomedical imaging and signal processing, remote sensing. And DSP, this technology of digital signal processing, is at the heart of these applications. In addition, as you know, there is a very strong connection between signal processing and machine learning. And actually, machine learning has a pivotal role in artificial intelligence, since it has a great many contributions to at least 2 top applications of artificial intelligence: speech and vision. So here's a summary of Professor Schafer's employment history, as well as some of his top distinctions in research and education. In conclusion, Professor Schafer has been one of the pioneers who actually co-founded the signal processing discipline, advanced the applications of digital signal processing to speech technology worldwide, and supported its applications to other fields as well. He has co-authored innovative, groundbreaking, and area-creating textbooks, both for signal processing as well as for speech. He has been a distinguished scholar and highly regarded university educator in the signal processing community and in other also scientific communities. And his numerous and prestigious top awards from IEEE and other societies are a small token of appreciation for his ethos and his contributions to education and research from the international research community. So, on behalf of students, faculty, researchers, and engineers in signal processing, congratulations, Professor Schafer, and many heartfelt thanks for all your contributions to education and research. Thank you.
I would like to call the Dean of the School of Electrical and Computer Engineering of the National Technical University of Athens to read the decision of the school about the honorary degree of Professor Schafer.
So we have to agree to use now another language that is still not recognizable by the vast majority of our young people. It's in the ancient style of reading. So, Εθνικό Μετσοβείο Πολυτεχνείων. Ψήφισμα της των ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολής, τύχη αγαθή, πριτανεύοντος εν το Εθνικό Μετσοβείο Πολυτεχνείο Ανδρέου Γεωργίου Μπουντουβή, κοσμητεύοντος δε εν των ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολή Νεκταρίου Γεωργίου Κοζήρη. Δέδοκτε τη σχολή Ronald W. Schafer, άνδρα εκ Νεμπράσκα των Ηνωμένων Πολιτειών της Αμερικής, ορμόμενων δια το φιλέρευνων και φιλόσπουδων και δίτα της θεωρίας και σχεδιάσεως των συστημάτων επεξεργασίας σήματος και ομιλίας, περαιτέρω καινουργήν και ταχαίως προάγειν, ομολογούμενον, τα της φύσεως αυτό αδίδακτα δώρα, ερεύνη, διφύτορη και ασκήσει πολυμόχθο εις τέλος άγοντα, πανεπιστημίων τε των υπέρ παν όνομα σπουδαστήν και διδάσκαλων, και πως θεωρίαν και έρευναν τη πράξη αρμότην και τα των καθεκάστην επιστημών εις το καθόλου συνερήν και την όντως αλήθειαν μαθηματικός ζητήν. Τον άνδρα των δε όλβο επικυλμένων πνευματικό, ερευνών τε και διαλέξεων, μαθημάτων τε και εκδόσεων, επίτιμον διδάκτορα της σχολής ανάδειξε και το παρόν εις μεμβράναν ανάγραψε, τον δε κοσμήτορα της σχολής εν τη αιθούση τη μεγάλη αναγνώντα και τα στιμάς ανίποντα επιδούνε αυτό ή αν ημέρε η αγόρευσης γέννηται καθά νενόμιστε. Εγένετο Αθήνηση μηνός Φεβρουαρίου 9η, έτη 3ο και 20 και της χιλιοστό από Χριστού γεννήσεως, ότι στον ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολής κοσμήτορ Νεκτάριος Γεωργίου Κοζήρης. Ευχαριστώ.
Now, I would like to invite the Dean of NTUA to...
Professor.
Dean? The Rector of NTUA, yes. To read the decision of the Senate.
Ελληνική Δημοκρατία, Εθνικών Μετσόβιων Πολυτεχνείων, πριτανεύοντος εν το Εθνικό Μετσοβείο Πολυτεχνείο Ανδρέου Γεωργίου Μπουντουβή, καθηγητού εν το Χημικών Μηχανικών Σχολή, Νεκτάριος Γεωργίου Κοζήρης, καθηγητής και κοσμήτορ της των ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολής, Ronald W. Schafer, ομότιμο καθηγητή εν το Ινστιτούτο Τεχνολογίας της Γεωργίας των ΗΠΑ και καθηγητή εν το Πανεπιστημίο Stanford των ΗΠΑ, αποδόγματος ομοθήμου εις των ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολής, εις τους Επιτίμους Διδάκτορας ενέκρινε. Εγένετο Αθήνηση μηνός Απριλίου 8η και 20η, έτη 3ο και 20ο και δυσχυλιοστό από Χριστού γεννήσεως. Ο ΠΡΥΤΑΝΗΣ Ανδρέας Μπουντουβής, ότι στον ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολής κοσμήτων Νεκτάριος Κοζήρης.
And I would like to call the Dean of the School of Electrical and Computer Engineering to read the text of the honorable degree.
Εθνικών Μετσόβιων Πολυτεχνείων, Αναγόρευσης. Επειδή η των ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολή του Εθνικού Μετσοβίου Πολυτεχνείου, Ronald W. Schafer, ομότιμον καθηγητή εν το Ινστιτούτο Τεχνολογίας της Γεωργίας των Ηνωμένων Πολιτειών της Αμερικής και καθηγητή εν το Πανεπιστημίο Stanford των Ηνωμένων Πολιτειών της Αμερικής, επίτιμον διδάκτορα, απευθύνατο, το δε Πριτάνη ταύτα έδοξεν, εγώ, Παναγιώτης Δημητρίου Τσανάκας, καθηγητής και κοσμήτωρης των ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολής, εμένων της του Πανεπιστημίου Νόμης και της συμμετέρας σχολής Δόγμαση, Ronald W. Schafer, εις τους επίτιμους της Σχολής Διδάκτορας Αναγορεύω και πάσας αυτό τας προνομίας, τας τόδε το αξιώματι παρεπομένας απονέμου. Εγένετο, Αθήνηση μηνός Σεπτεμβρίου, 11η, έτη 3ο και 20ο και δισχυλιοστό από Χριστού γεννήσεως. Ότι των ηλεκτρολόγων μηχανικών και μηχανικών υπολογιστών σχολής Κοσμήτων, Παναγιώτης Τσανάκας. Ευχαριστώ.
I would like to invite the Rector of NTUA and Professor Ronald Schafer, as well as the Dean of the School of Electrical Engineering of the National Technical University of Athens. Professor Schafer, now we will receive the honorary degree from the School of Electrical and Computer Engineering of the National Technical University of Athens.
In front of the table. Please.
And now I would like to invite Professor Ronald Schafer to talk about engineering education changes the world.
I was that you were all talking about. I'll have to do my best to represent him today. I'm deeply honored to receive this degree. I must begin by thanking the many people who made this possible, starting with Professor Boudouvis, Rector of NTUA, one of the world's premier technical institutions. Thank you to Professor Koziris, former Dean, and Professor Tsanakis, Dean, and the faculty of the School of Electrical Engineering. It is especially gratifying to be recommended for this honor by my electrical engineering peers. Special thanks go to Professor Maragos and Professor Rondoyanis for thinking that I am worthy of such an honor. And thank you, Dorothy, for being by my side through life. And finally, thanks to all my students for all they've taught me over many years. I'm extremely grateful to you all. There's abundant evidence that engineering education has changed the world and continues to do so. But I think that we often underplay the importance of education in the development of the technologies that directly impact us every day. My own education in the field of digital signal processing, or DSP as I refer to it, is a case in point. First of all, what is DSP? Simply stated, it's the representation of signals such as speech, music, video, etc. as sequences of numbers that can be transmitted, stored, modified, and even automatically interpreted using digital computation. Digital signal processing blends mathematics and computation to create solutions to problems in a wide range of application areas. Though it may not be obvious in some cases, some of the many things that DSP has already enabled are shown here. It's a hidden technology. Some people call it a stealth technology. All of these and many more are enabled by digital signal processing. None of these things were possible when I began my education in DSP, but today it's hard to find something that is not enabled by DSP, including the hot topic of AI. I think that digital signal processing will continue to be a critical enabler of almost every human-made object or system. So I believe that every engineer and scientist should learn what digital signal processing is, what it can do, and how to use it to solve their problems. Let me hasten to clarify, in spite of what might have been said here today, I am not claiming to have invented DSP. As Professor Marigold stated, I've done DSP research, published papers, written textbooks, taught classes, and advised graduate students, but so have many other outstanding people, including many professors and graduates of this great institute. My point is this: engineering education in the form of textbooks, classes, research papers, conferences, and short courses has taught the fundamentals and advanced topics in the field to thousands of engineers who have used what they learned to create the objects and systems that we enjoy today. I just feel fortunate that I've had a small role in this great story. I started out as a boy from a small town farming community in the middle of the United States. Like many people who become engineers, I like to figure out how things work and to fix them when they quit working. DSP did not exist in 1956 when I started my college education at a small liberal arts college. But there I encountered the first of several great teachers who helped me to learn DSP and much more. Levi T. Wilson had retired from a long career in the U.S. Naval Academy, but he loved teaching enough to become the entire mathematics and physics department of this small college of 350 students and 30 professors. He taught me the beauty of applied mathematics and inspired me to want to be a teacher too. I enrolled in electrical engineering at the University of Nebraska, where my EE education focused on electric circuits, vacuum tubes, and machines. The world as it was then, not as it would become soon. In 1963, I traveled east to MIT, where an inspiring teacher named Thomas G. Stockham showed me new ways of thinking about signals and systems, and later he introduced me to Alan Oppenheim, who became my doctoral advisor, colleague, and friend for life. About this time, transistors were replacing vacuum tubes. Digital computers were becoming available, and it was recognized that these were the components of the future. DSP sprang to life in 1965 with the disclosure of a computational algorithm called the fast Fourier transform, or FFT. There were no DSP classes or textbooks, so my DSP education began then with reading and mathematics paper. When I finished my doctoral thesis in 1968, I became a researcher in James Flanagan's acoustic research department at Bell Telephone Labs. Jim was an extraordinary researcher and research manager. Working with Larry Rabiner under Jim's mentorship, I learned to do engineering research and to report on it with clarity and integrity. All these extraordinary teachers prepared me at last to be the teacher that I had set out to become. In 1974, a very persuasive Greek named Demetrius Paris hired me to teach DSP at the Georgia Institute of Technology. Under his mentorship, I learned to be a professor, and for the next 30 years, I worked to advance the field and to introduce many students to DSP. By 1974, I had co-authored the textbook that Petros mentioned on digital signal processing with Alan Oppenheim. The book was arguably the first textbook on digital signal processing, and it contributed to the advancement of the field by stimulating graduate-level DSP courses at schools besides MIT and Georgia Tech. These courses typically focused on textbook reading, homework, and exams, that is, pencil and paper activities. The content of DSP courses changed, however, rapidly to keep up with new design methods, new algorithms, new theory, and algorithms that emerged from research and new applications. By the early 1990s, personal computers and software such as MATLAB became widely available, so that a laboratory for experimenting with DSP could be available in every student's personal computer. This led my colleagues, James McClellan and Mark Yoder and me, to the heretical notion that DSP was a more fundamental subject for EEs and computer engineers than even traditional linear circuit theory. And amazingly enough, we managed to convince our Georgia Tech EE colleagues of that. In 1998, we published our book along with a CD-ROM containing all the computer demos, laboratory experiments, and homework assignments that we had developed for our sophomore level introduction to DSP. As a measure of how fast technologies are changing today, most computers now have no capability to even read that CD. DSP enabled the digital storage of music first on CDs, and then today it enables streaming of music and video over the internet. As many predicted in the early 2000s, we are now surrounded by a virtual cloud of information, powered by a vast array of computers and memories, which brings us up to the present time. Looking backwards, I see that there have been at least 3 generations of engineering students that have learned about DSP and used it to change our world. I'll call the first generation the founders. Most of them learned their DSP with pencil and paper, although some lucky graduate students like me might have had access to a dedicated hands-on computer that could be used to experiment with speech and image signals. The second generation, which I call the builders, had the benefit of integrated DSP chips, personal computers, and sophisticated design software as they produced real-time systems for speech and video coding and other applications. The third generation, which I call the expanders, gave us smartphones, and they realized that brute force computing on lots of data could solve problems that earlier generations had sought to solve with cleverness and detailed models for signals. Clearly, these 3 generations have dramatically changed our world. Now we're at the beginning, I think, of a new generation that I call the Zoomers, for lack of anything else, because their DSP education... Should we wait?
Chasing us.
It's not unusual.
Oh, there they go. I call them the Zoomers because their DSP education started with online video courses during the COVID-19 pandemic. Incidentally, Zoom is something that is clearly enabled by DSP. I've observed that the Zoomers are impatient with learning the fundamentals, particularly mathematics. They prefer to consult the internet, and recently another new technology has appeared on the scene which makes this easier to do. Generative AI systems such as ChatGPT are designed to generate new content such as images, text, music, and more from the vast content of the internet. These systems are capable of creating new data that is similar to or inspired by existing data that they have been trained on. Of course, signal processing enables much of what people are calling artificial intelligence, but I want to focus here on the implications of generative AI for engineering and engineering education. Some professors are fearful that this technology will be misused by students to avoid the hard work of thinking and writing. And given that students have all the weaknesses of the human race, that is sure to happen if we continue to operate as we have in the past. However, rather than bemoaning something whose progress is inevitable, I believe, we should embrace it, because generative AI has the potential to revolutionize a wide range of human activities, including engineering education and the practice of engineering. I've been teaching a course on DSP at Stanford University for a number of years. My teaching colleague, Fernando Mujica, and I have found that our students prefer classroom interaction with real problems to traditional lectures. We assign readings and or video as preparation, and then use class time to solve problems. Tablet computers facilitate the interaction. This is one of the benefits of being at a university like Stanford, where they can check out iPad computers to students. In any case, students also do DSP programming experiments on smartphones and iPads. Now we're thinking about how to work chat. Even though generative AI is in its infancy, I'm amazed at some of the things it can do, but worried about how its humanoid responses can make you believe what it says is fact. I've been giving ChatGPT DSP problems, trying to see how engineering students and engineers might use it to learn the subject and later in practice. I'm easily impressed, but still see many issues. Here's my experience with a few of the many possible uses. Simple concept explanations work, but complex explanations are often wrong or oversimplified. Input and output with LaTeX makes mathematical manipulations possible, but algebraic manipulations are often wrong. MATLAB and C++ programs are written from text specifications, but they may have bugs or may not be efficient. So far, if ChatGPT were a DSP student in my class, I'd give it a C- grade. So it would not be wise for students to rely on it for answers. It will be important to teach students, I think, that they should question everything. They need to learn how to ask follow-up questions that lead to correct answers, and most importantly, be able to recognize a correct answer when it's given. It is with mixed feelings that I recommend embracing this technology. If you believe ChatGPT itself, and I ask it, the energy cost for one query can be on the order of 10 watt-hours or more. This is the amount of energy required by a 7-watt LED bulb on for more than an hour. This seems to me to be a serious concern that will have to be addressed. With hundreds of millions of queries per day, this adds up to a huge carbon footprint. Nevertheless, I think that generative AI will get better and better, and maybe even improve its energy use. It will eventually be a powerful tool for education and the practice of engineering. But it is my fervent hope that it will always be used as a tool, not a teacher replacement. Teachers do more than pour information into young brains. My teachers, shown here again, shaped my life in ways that no machine could ever match. I thank them all for that. In conclusion, I want to again thank the faculty and leadership of NTUA for the great honor that you have given me. It is humbling to join the ranks of the graduates of this great university. Thank you.
I would like to invite the Dean of the School of Electrical and Computer Engineering to offer the honorary diploma degree to Professor Schafer.
Am I supposed to open it?
No, now I would like
Is he supposed to open it?
No.
Okay.
I would like
If I knew how to juggle, I have
to
three.
offer the honorary medal to Professor Schafer.
Here you go.
That's the medal.
This is the emblem of NTUA. It's Prometheus. Thank you.
I've often said that we have Prometheus to blame for our carbon problems today.
Βεβαίως και είσαι λίγος.